So I learned about waves and their impact on me, leaving Woods Hole in a nor'easter, and boats rolled, and I get seasick. So while heaving in the Noir, in the hold, I became a coastal engineer. So why am I up here talking about waves? Well, the Corps cares about waves, but I arrived in the IUCN in 2000. I asked the question, what about waves? And IUCN didn't care about waves back then. But if you're a sea captain or a Coast Guardsman or a surfer or any one of these scenes, you care about waves. We all use the same information, but we require different accuracy for what we do. We want to move sediments. This requires the highest accuracy of wave observation that you can get. But if we satisfy that, everyone's happy. There's a handful of folks, these are the rock stars of the wave world. Because of what they've done, if we know the winds, we can forecast the waves anywhere on the planet. There's lots of ways to observe waves, but most of these are flawed. Waves are big and long, sensors are small, and many of these sensors miss the details. And in waves, the details matter. And of course, we're going to use all our available observations to calibrate our satellite altimetry or our wave models. But what if the buoy observations are wrong to start with? The collateral impact can be significant. And this is what we're finding out. So let's look at some waves. Here's some easy ways to measure clean hurricane swell coming from the south. We measure this with a directional spectrum. You can see there's just one peak. One wave height, surfer's delight. This is pretty easy to measure. However, the more normal condition is waves from all different directions. Look at the directional spectrum, lots of peaks. What we want is an observing system that can measure accurately the whole range of wave conditions. You can't get a 10-foot wave in 5 feet of water or in 10 feet of water because at the coast, waves are depth limited. They break by depth and too shallow. But even so, even though the waves are capped at the coast, the bigger the waves are offshore, the more beach erosion occurs. What's going on? Well, the waves are pumping energy into the surf zone, and that manifests itself into wave setup, which raises the water level, and wave run-up, which impacts the dune and the beach and causes beach erosion. Of course, during hurricanes, it's the storm surge that controls the level of impact, but it's the waves that cause the destruction. During Hurricane Ike, the 20-foot storm surge over this barrier island, this was like a sandbar, and the waves cleaned house or houses. Of course, climate is changing, and we know it is, so we expect to see some sort of change in the wave climate as well, but how will it manifest itself? And there have been studies to look at this using the available data. Well, what about the available data? There are 200 active wave observation sensors out there now. Of those, 60 have a 20-year record. These are our sentinel wave stations. These are very important if we ever hope to look at wave climate, that these be sustained. 11 of these sensors have 34 years of record or more. 2 have 38. If the climate signal isn't really strong, 38 years is not enough to see the trend. And to make matters worse, none of these were put out with climate in mind. So the buoys have been moved around, the platforms have changed, the sensors have changed, the software to analyze them has changed, so you can't just string the data sets together into one long record. At least you shouldn't, because it's not the right answer. So let's look at a long record. We have one from Duck, North Carolina, 28 years. The dots are 250,000 observations. The red line is a monthly mean. You can see there's a clear seasonal trend, summer lows, winter storms, very few extremes. The blue line was a trend. There was no trend. We expect really the climate change just manifests itself in storms. So here's the storm record, and here I'm plotting wave power delivered to the beach. That's sort of what the beach is responding to, and it really makes the storms pop out. Do you see a trend? Well, if you fit a line, there's a positive slope, but be careful. The extremes are very infrequent, and there does look like sort of a periodicity there. It's just not long enough record. We need longer records. So in summary, waves of the coast are complex. We need to measure them. Big waves cause big changes, but it's difficult to understand at the coast. Wave climate's even harder to measure. We need to improve the accuracy of our instruments. We need longer records, and we've got to sustain these sentinel buoys. So I hope that you won't look at a wave the same way ever again after today.